welcome on the KIN-MATICS channel, set up of mathematics. Okay, today we shall be looking at this problem, which is the integral of x power 4 plus 1 power negative 2 dx. Okay, well, what is it equal to? We shall find it out. Let's first, but before we start today, we are going to look on something. This name here, it is the Ostrogradsky Method. Oh my god, the name is so complicated to read, but we shall see. What did this guy say? This mathematician once say that if p of x and q of x are functions with q, we're having repeated loads, and p of x over q of x is a proper fraction. What does it mean? Meaning the degree of the numerator is greater than the denominator. Okay, it said if this q of x is, remember, it is a repeated, meaning maybe it is a function like x plus 1 power 2 power 3, being repeated. That's what it means. So this function, it is equal to this p1 of x over q1 of x plus that. Wow, so easy like that, where q1 is the greatest common divisor of q, which is q of x, and the derivative of q. Wow. And we find this one using Euclidean algorithm. My god, I'm finding hard names in this problem. Okay, now for q of 2, we get it by dividing what we have got, the original function divided by what we have just got there. We shall see how to get them. And we get p of x, these ones, p1 and p2. For it, we get it by differentiating this equation here. We see, when you differentiate it here, maybe we introduce when you differentiate here, you get that. You get p of x over q of x. When you differentiate this one, of course, they remain the same. When you differentiate this, you get that, as we have seen here. So you first decompose this to partial fractions, then you compare such that you can get those things. We shall see how you do that. Okay, now let's go back to business. That was just a recall. Now, this function here can be written like this. As the power goes down, it becomes a positive, like that. Okay, now meaning this is a repeated thing because I'm seeing power 2, so it is repeating. So meaning now my q of x is automatically that, and when you differentiate it, you get it. You get it. Okay, now q1 means it will be the greatest common divisor of this function here and that. Okay, but however, let's see, for q1, you just get this original function, subtract the power by 1, you get it. So that is it. And for q2, I'm just gonna get this one, I divide by that, I get that. So they are the same, but however, getting them in different ways. For p of x is 1. It is a function, but it is equal to 1. So nothing to calculate there. Okay, now, meaning I'm substituting now back. Remember, our formula is here. Our formula is here. I'm substituting these stuff here. So they will be like that. Wow. Now, after me realizing that, see, this is x power 4 plus 1, meaning as I'm decomposing it to partial fractions, the power should start with 4 minus 1. I think that is 3. So I have to start with ax power 3 plus bx squared plus that. The same stuff even here, as I'm going to do the same stuff. Okay, now after me doing that, remember our formula says, we said it, the formula is, when you differentiate, I remember you know this formula which we talked of, like when you differentiate this stuff here, you get it. Okay, now I have said my p of x is this. So meaning, instead of here, I'm gonna write that, and instead of I'm writing that after. Okay, now I'm going on. Now I'm going to differentiate this. When I differentiate this, I get that, and when I try to go on after me differentiating, I go on